here's the third set of practice problems or examples where we are using the graph of f to find the given limits. When necessary, state that the limit does not exist. So let's see. So same exact picture we were working with, but this time we're interested in what's happening at x equals -4. So I'll do the same thing. I'll copy this and I'll paste it up here. See what's happening at 4 or -4. So the first one is asking us what's happening as x is approaching -4 from the left. Okay, so we're looking for the left hand limit. That little minus sign is telling us to approach from the left. This one, we're trying to approach -4 from the right. So this is going to be the right hand limit. Okay, and I try to make these examples to have the same pattern. So the third one that I highlighted in green right there, we're looking for the general limit. This answer for C only exists. The answer for C exists if and only if the answer from A and B, the left-hand limit and the right-hand limit, are exactly the same. So let's see if they are the same this time. So where is -4? Let's find -4 on the x-axis. So that's -5 right there. So -4 must be 1 to the right here. That's -4. Look and see what's happening. Okay, we have an open circle here at 4, but we also have a closed circle up at 6. Okay, now this is interesting because when we look at the x value of -4, we have two circles on top of each other. Now let us do the left-hand limit first. So which graph goes to the left of -4? The little parabola right here or this square root looking function right here? This parabola. See, this graph is to the left of -4. And this graph is approaching 6. The f of x, the function value, is approaching 6. This closed circle as we approach -4 from the left. So the left-hand limit is 6 because that's what the graph to the left of -4 is getting close to as it gets close to -4. Now let's read the right-hand limit, okay? Let's get on the graph that is to the right side of this dot. So I am going to that, I'm on that line, and it looks like we are going down to the y value of 4. So the left-hand limit and the right-hand limit are different this time. So the left was going to 6, the right is going down to 4. They did not meet, right? They are broken apart over here. So what would you say for the general limit? 6 and 4 are not the same, right? So you're going to have to say does not exist. DNE for does not exist, okay? And what I mean by DNE is does not exist, okay? I'll write that down. Because, if you want to know why, because I'll say that the left-hand limit, which came out to be 6, right, does not equal the right-hand limit of 4. 6 and 4 are not the same, so when they're not the same, we have to say the general limit as x approaches -4 does not exist, okay? Now, what about the function value at x equals -4? Remember, for function value, like f of -4, you're looking for the closed circle. Okay, look for the closed circle. Where's the closed circle at? Right there, right? And that is up at 6, not at 4. So the closed circle is at 4, 6. So the function value is 6. And the last question is it continuous at -4? Does it look continuous? Can I graph this, without lifting my pencil at this point? No, right? And what we're gonna say is, and I'll write that down here in the blank. Give me 1 second. Maybe I can just move this down. Hold on. Yep, that works. I will say f is not continuous at x equals, I forgot what number we were looking at, -4, because, I mean, we have to compare these two. We have to compare these two, and only if the general limit equals the function value, we get to say it is continuous. But the general limit doesn't even exist. So let's say that's why it's not continuous, because the limit as x approaches -4 of f of x does not exist. And honestly, continuity is a topic in 1.2. I'm kind of giving you a preview right here. But the continuity will actually have 3 parts, okay? So number 1, you must check and see if the function is defined at that value 8. A, okay? Like given like number 4, okay? You better have a closed circle or a function defined at the given value. Number 2, you need to make sure that the limit exists. What's the limit as x approaches that given value of the function? And guess what? Number 3. Okay, like assuming that the function is defined and the limit exists, the third thing that you need to check is that the function value, the answer from part 1, better be equal to the limit as x approaches that number of the function. And if these 3 conditions are met, then you get to say, yes, it is continuous. But we'll talk more about that after 1.2 when we evaluate some limits. But I just wanted to kind of create examples that are leading us to that. You're always going to find the limit, the function value, and you'll make a comparison. If they are the same, you get to say, yes, it is continuous. But if it's not defined, or if the limit doesn't exist, we have to say it is not continuous at that given point, okay?